Okay, so this page here is just, you can skip this page, it just talks about, it's just like a quick little check. Can you, without looking back, fill this chart in as much as possible? If all else fails, just fill the top first quadrant in, because once you know the first quadrant, you know all the other quadrants. So pause the video, try this out. Okay, so here's what I've done so far. I just put the coordinate points down. I put the quadrantal ones too, because those are important ones to know, like 1, 0, 0, 1, and negative 1, 0. And we already did the 270 before, it'd be 0, negative 1. I think that's what we put up here, didn't we? Yeah, 0, negative 1. Okay. You can put some angles in here too. So like this angle here is, if you put this in degrees, this would be 30, 45, 60, and then 90, and this is 0, or 360, depending which way you're going there. Putting some other ones in here, like 180, 270. You can change all those into radians if you want to as well. I'm not going to complete the whole thing. Whee. Okay, so we're almost done this section, part 1. We're going to do part B in a second here. So there's a table here we're going to fill out. So this is very similar to what we just did up previously. I'm just asking a few different questions. And this time we're going to use exact answers. There's coordinate points here on the 360 or the 335. So we want to know where on the unit circle, where that point is. Is it half and root 3 over 2? Is it root 2 over 2 over 2 over 2, depending if it's like a 45-degree angle? Well, first of all, let's figure out where it is. So 330 is right here. There's 330. Let me just label that out. Its reference angle, because that whole thing would be 360, if I minus the 330 out, I would get 30 degrees. Lands in quadrant 4. Now, Roman numerals are numbers are fine by me, right? The coordinate there, assuming that this is on the unit circle, doesn't specify that. So let's assume that these are to be on the unit circle. I'm just going to put that at the top here. The ratio would be the same no matter what. If it wasn't on the unit circle or not, the ratio would be the same. But the unit circle, the coordinates of that point are different if it wasn't on the unit circle. So 30, it's a 30 triangle. So if I were to kind of draw a triangle there, how big would that X and that Y be? So sine would be the Y. Like sine is always the Y. Like we already know that. So this, remember, this would be sine theta, cos theta. So sine is the Y. Oops, sorry. That's backwards. Sine is the Y. You weren't saying that, but I wrote it in the wrong spot. And cos is the X. Okay. So sine 30 is a half. It's going down. So it's a negative. Hex is positive, so root 3 over 2. So those are always kind of paired off with each other. The root 3 over 2 and the half, they're always going to pair. Now this is sine. Sine is the Y value, so this is going to be negative a half. You can type in your calculator too. Make sure your mode is in the right mode. Degree, sine 330, negative a half. Cool. 180. So let's draw the 180 there. 180, this point, well, actually the reference angle to the nearest x-axis, if you're on the x-axis, the reference angle is 0. 180 minus 180, it's 0. You're not in a quadrant. This is what we call a quadrantal angle. So you're in neither quadrant. You could say which two quadrants you're in between. So you're in between 2 and 3. Right? But you're not in a quadrant, which is what we call a quadrantal angle. On the unit circle, the point would be negative 1, 0, and we're talking about sine, so this would be 0. So I can go to sine 180, my calculator, I get 0 as well. Okay. 5 pi over 6. So that's 150 degrees. So we are in this quadrant here. 5 pi over 6. Even though I just quickly change it into degrees to figure out where to draw it, we still have to answer all our questions using radians. Okay, so this one here, to find out my reference angle, the whole top piece is a pi, and I'm going to minus 5 pi over 6 from it. So I'm really just going 1 minus 5 over 6. So that's going to be 1/6. So pi over 6. We're in quadrant 2. This point, now the reference angle 1 over 6, I'm going to put that in parentheses so I know what it looks like. 1 over 6 is 30 degrees. So that's technically a 30-degree triangle there. Okay, so that means that's 30-degree triangle. The y is a half. X is negative √3 over 2. We're doing cos, so that's my x values. So √3 over 2. You can double check that too. It's going to be a negative number too. So if you make sure your calculator is in the right mode to do that. 4 pi over 3. $240. 240 is in this quadrant. Right about there. Okay, so this is going to be 4 pi over 3 minus a pi to find out what this one is. So this one's going to be pi over 3. Pi over 3 is 60 degrees. Okay, we're in quadrant 3. So this is a 60-degree triangle this time. So that means the longer side here, because if this is this pi over 3 here, the longer side is the y value. So that means that's the √3 over 2. √3 over 2 is bigger than 1 over 2. And the x value is also negative here. Okay, cool. Now my ratio, this is tan. Remember, tan is y over x. So that means I'm going to take my y value and divide it by my x value here. I'm trying to figure out a way to write this. 3 over 2 divided by a half. You notice I got rid of the negatives because, well, actually I'll write them both in there, but they both become negative divided by negative, become positive. So this would be √3 over 2. We did this math, the very similar math before. Take the reciprocal, reduce those out. This ends up being positive √3. Cool. Negative quarter pi is down in this quadrant. That's the negative quarter pi. That's 45 degrees. So this will also be quarter pi, but not negative, right? Reference angles are always positive numbers. This is a 45 degrees. If you want to change that, you could. This is quadrant 4. The point of a 45, remember the 45s are √2 over 2, √2 over 2. You can write that as 1 over √2, or 1 over √2. Now, because we're not in the first quadrant, so these both can't be both positive, so we have to figure out which is positive, which is negative. So the y is going down. So that means my y values are negative, but my x values are positive. Okay, because I'm going to the right. And this is cos. Cos is my x. So it's √2 over 2 or 1 over √2, depending on how you want to write that. Cool. Okay, so we're going to pause the video. You're going to try that yourself as well for all of these. You see some are bigger than others, like 690. You'll have to find the principal angle for that. So like minus 360 from it. But you're going to try all of these, and then I'm going to pause the video, and then the next time you see this video, all the information is going to pop up. So give it a good try first. I'm back. Just want to fool you.